Hello, I'm here to talk to you about the chain rule. The chain rule is a very powerful rule when it comes to differentiation and opens up a whole new set of possibilities when it comes to differentiation. Consider our first example here. 3 bracket 2x squared plus 5x raised to the power of 6. How would you differentiate that based on what we know already? Well, we don't really have a way of doing it apart from to expand out 2x squared plus 5x to the power of 6, but that is a very, very long expression. Fortunately, there is a rule called the chain rule, or function of a function rule, which I'll be happy to explain in class why it's called that and how it comes about. But anyway, it makes it rather easy to do. Really what it involves is this. Look at the exponent there, it's 6. You take it out the front, and so it becomes 6 times 3. You rewrite what's in brackets, 2x squared plus 5x. You lower your exponent by 1 in the kind of usual way from the differentiation by rule stuff we've been watching. So you decrease that by 1. But then what you do is you multiply by the derivative of what's in brackets. In other words, the derivative of 2x squared plus 5x. Or in other words, 4x plus 5, isn't it? Okay, so let's do that now. So it's going to equal 6 times 3. Just rewrite what's in brackets, don't touch it. Reduce your exponent by 1. That step shouldn't come as a surprise. This one does though. And you times it by the derivative of what's inside the bracket. So that was, but we're going to need brackets here too, aren't we, because there's more than one term. So the derivative of what was in brackets was 4x plus 5. Okay, and that's nearly it, except we would tidy this up a bit. So 6 times 3 is 18. Let's bring the shorter expression, or the lower powered expression, out the front. 4x plus 5. And then rewrite the second pair of brackets. Not doing much there. And finally, I would get rid of the 18. So 4 18s is what? 36 times 2 is 72, so it's going to be 72x, and 18 times 5 is 90. That should be in brackets, and again just rewrite what's over here. Okay, and that is our first example of the product rule. Okay, let's have a look at another example. Now, this really does, I think, show the power of the chain rule, or function of a function rule, because what we can do here is say that y is equal to -7 bracket 5x minus 2 raised to the power of -9. So we can bring that upstairs, the denominator upstairs, as long as we change the sign of the exponent. And now what we do is we apply the chain rule, or function of a function rule, in the usual way. There's nothing extraordinary about it at all. So dy dx, we're using dy dx notation for this example, is equal to -9 times -7 is +63, and we've got 5x minus 2. Don't touch that. Now we've got to reduce that by 1, the index by 1, and we've got to times by the derivative of what's in brackets, which is 5. Now all that remains to be done is to tidy it up a touch. So we'd say therefore dy dx is equal to, I think you'll find 63 times 5 is 315. Now we really should put our 5x minus 2 downstairs again, and we can do that easily by just changing the sign of the exponent or the index, okay, to positive. And that is our final answer. That is our first look at the chain rule. Okay, bye for now.